And here today we're going to talk about mostly React class components. So I got a question, and the chat is just fine. Why why would we be talking about React class components today, even though we've only really talked about hooks for the most part? And I'll leave it there. So why class components today? Yeah. So yeah, legacy code is probably the only reason to really think about class components anymore. And I can only think about one feature of React right now that actually requires us to use a class component. Oops. But other than that, there there aren't any features that I can think of. So the one feature happens to be related to error boundaries, but it's no problem because we can still create a class component for that. I don't know if there will be a hooks based replacement for that concept of catching errors. Uh, but right now, obviously, it's not a priority for the team. So for now, we'll just have to kind of accept that there is maybe one reason to do it. Uh, so that means that what we really need to focus on is sort of what some of the differences are between the class components and the hook based or functional components that you've been using so far. And then we can kind of just try and apply some of the things we've learned about props and state and React elements and all the things that are common between all the APIs, and sort of just try and apply that to class based components. So the major differences I will highlight. You will be doing a few activities today where you will be building a small application using classes instead of functions, and today, the example happens to be a multi-room real-time chat with a WebSocket backend. So to me, that's how I made class components exciting, or this lecture maybe a bit more exciting or interesting. Is I find class-based components to be basically a thing of the past. They're not fun to talk about anymore. They're really not fun to use anymore. The first time that I used them in about a year was to prepare this lecture, and when I was writing the code, it just made me think about how little I miss them and how much I like the new API with functions. So, as an effort to make up for the boringness that comes with class components, I decided to also provide examples of how you might use WebSockets to create a real live, like a live chat room. And you could take these components and look at them and yourself convert them over to functions to practice how to actually how to do that yourself as you go into the workplace and have to start to take maybe some of these legacy components and switch them over to use hooks. You could practice in an app like this if you wanted to. So hopefully this could be taken further, maybe after boot camp. Doesn't have to be right now, but it'll be there for you if you're interested. So I'm gonna share my screen and make sure that you can see it nice and clear. All right. So let's talk about the motive for creating hooks in the first place, because I think it's important to understand sort of where we came from, where React came from, and where React is now, where you're jumping into it, and have a little bit of an idea of what the history is and why hooks were even designed in the first place. So you've read it by now that hooks let you use more of the React features without classes. So this is actually quite a nice thing. And the question is, well, why would we want to avoid classes? And so if you actually just go right to the documentation for React, where they explain why they decided to use hooks, this is where I lifted the information from. The three reasons that they decided that they were going to go after a more functional API for React. Number one, it's hard to reuse the stateful logic between components. So um, there's a difference between component responsibility and the code within a component. And some of that code is responsible for logic to create data that can be rendered. And then the other part of that component is responsible for rendering that data. And sometimes we want to render things differently. We want to render the same thing differently. And so we might want to reuse the logic that creates that thing in a few different uh, components. And with classes, that was harder to do. But with these functions that we can package up, put it as a custom hook, and then share between our components, that makes it a bit easier on us. And I know when I use the term easy, that's not quite fair to any of you. But when I say easy, I mean relative to what it was before, some of the things that we would have to do and the patterns that we created or that I learned from other people that created them to get around this issue of not being able to easily share logic. There is a history there of different solutions that we've now come to, hooks being the main one at this point. And it could change. Who knows? Uh, who knows? So number two, complex components become hard to understand. So this is actually very true to me that as with classes, we really just have to. It's very structured. We don't really get a lot of choice in how we structure it. So, for example, all the stuff that we want to do when a component loads up has to go into one area, and that's defined for us when it comes to class-based components. Whereas with hooks, we can create as many use effect calls as we want, and we can separate them out into different responsibilities if we wanted to, and then ultimately pull them out into their own custom hooks. Going back to the first point where we get to share logic easier. So by we can reduce the complexity of our components by hiding the complexity in a custom hook and having a nicer, clean interface. Something, for example, like the visual mode hook that we created. The purpose of that was not necessarily to share that between multiple components, although if any other components needed to have some sort of a history state, then that could be done that way. But instead, the responsibility or the benefit we gain from doing that is we only really care about three things: the mode, a function that knows how to transition, and one that knows how to go back. And if we know about those three things, then we don't have to care about the internal complexity that comes with it. That person who wrote that hook can deal with that complexity, but the user of the hook can reduce their complexity in the component itself. All right. And here's this last one, which I don't really want to go into because this is where I find it's easier for people to argue about semantics that don't matter so much. So classes confuse both people and machines. One of the examples that the React team has put on their site is that when we use classes, we have to think about this context. So the keyword this, and that is confusing and hard to do. And I say, yeah, that's true, and that was probably one of the hardest parts of teaching class components to students previously. But we haven't really changed anything in terms of complexity because we still have closure to deal with. And so we've just switched from this context to closure, and now we have to learn a complex topic like closure, or one that seems quite a bit very complex. Uh, we have to learn that still. So I wouldn't say that by switching over to functional React, we've really reduced the overhead. I would say use effect is actually more complicated than the class based equivalent, but also I believe it's more powerful. So that's the trade off. Okay. So I've got this slide here, and it represents a bit of history. So can anyone share with me in the chat or with voice why I have a slide that looks like this? ES4 is dead. Yep. So ES4 never made it out of the design phase. That we skipped from ES3 to ES5. So in 2009 was ES5. And so what happened in 2016 then? New champ. Maybe rise. The idea is this represents like a rise from the grave. Maybe I should actually put the grave symbol behind the hand. But essentially, classes have risen from the grave, and classes finally came with a specification for ES6 exactly. So even though, and there's a lot of history back in 2003, uh, there were arguments about what should go into ES4. One of the proposals was classes. ES4 never made it out because of a lot of drama around these arguments, and ultimately, ES6 did have class definition in it. So we have classes in ES6 now, whereas before we didn't. So um, if ES6 classes, this is the way that we built components before we had hooks. If ES6 classes came from 2016, React is from 2013. How did people create components between 2013 and 2016? So this is an interesting point in time where we didn't have ES6 classes, but we still had React. So how would someone create a component before classes? It's okay. I mean, this one is a little bit harder to know unless you go look it up. But basically, there was an API before ES6 classes that allowed us to create classes, and those classes would have functions in them, and they would have specifically a render function, which is important. That would be probably be the most important function available within the class, the one that knows how to create React elements and then return them. So this is what a component would look like before we had ES6. So between 2013 and 2016, you have components that look a lot like this. Okay, we don't have to learn this. I don't expect you to see these in the wild. This is not the case really anymore. I would expect more to see ES6 classes. So this is how we would also create a class uh, before ES6 in vanilla with vanilla JavaScript. So whereas here React is providing a function, a helper function, that if we pass it an object that has a bunch of function definitions in it, it will return to us a object that has inherited functions from React as well. So things that know how to set state and stuff like that. So this dot set state, for example, I don't have to declare that on my own class. React provides that to me in the class that comes out of this function. Okay, so here, basically, React is creating a new class, attaching a bunch of properties to it and functions to it, and then providing that, and then that's what actually gets created with this as this component here. So it's not a lot different, but it does have syntactical differences, which is really a lot of what we're dealing with the classes in a lot of cases. So, any questions about this function here, or this code and what it's doing and how this works? Is this syntax unfamiliar to anyone before I move on? Is the concept of a class something that people are unfamiliar with? This idea that we can create a prototype of an object and say and name it and create new instances of that object by passing in values like this. So here I create I want this object that represents a point. And at the end of the day, the properties inside of that object happen to be x, y, and a function that knows how to get those properties, this dot x and this dot y, which happen to be internal to this class. They know how to get access these, and they can return an array that has them x and y in order like this. So every time I want a new point somewhere, then I can create a new instance of this point function object. And it has every single one that I create will have a get position function available. We'll call that an instance method or instance function just to keep it more consistent. And this function has access to all of the properties within the object through this context here. Okay. So I didn't get any questions, so I'm going to keep going. This is how we had to do it before ES6. And what we have now is a syntax that really provides the same functionality, but in a way that matches other languages more. So this is a JavaScript, very kind of JavaScript way to do it with prototype inheritance. But this here is more of a syntax that is familiar in things like C++ or C sharp. More C sharp is what this is familiar as. Maybe Java, those languages that have a lot of classes. This looks a lot more like those languages. But the same idea, right? I have a class. It has a constructor. The constructor is the method that gets called when I call new on the class. I can pass arguments and create local or instance variables on that class. And I can create functions that can access those variables as well. Okay. So we're going to go from a class syntax in JavaScript to a class component in React. And so the difference mainly here is that my class, this is a base class. It has no extend keyword here, which means it doesn't inherit any behavior from any other class. There is no other capability that I have with this point. Whereas here, this point extends a component, and a component is a special type that React provides to us that knows how to do things like set state or access its own props, for example. We can see here, this is sort of the minimal representation of a component in React. You must have a render method. If you have a render method that can return things, those things can access props that are passed to this component. So the syntax is different, yes, but the concept is still the same. This component still receives props the same way. Some parent of this component will use JSX to pass an X and a Y prop to this point, and those are accessible right here as this dot props. And because it's not a function anymore, it's a class. So it's an instance of the class, this dot props, that is available within the render function, let's say, or all functions within the class. But so this kind of brings up this idea that we've got these classes, and this component here actually doesn't make sense to make this a class. I don't think there's any reason to make this a class because there's no state, and there's no necessity of understanding the life cycle of the component or being able to do things based on the life cycle. So that means that we can very easily take this component and convert it to a function and make it pure. So this idea of a pure component is one that takes in props and returns React elements, and it doesn't do anything in between with state. There's nothing that can change the behavior of what this component returns, and the only way this component will return different elements is if we change the values of X and Y. So typically before, I would write all of my pure React components using the functions still. And then I would write all my components that needed state as classes. And I would try and reduce the amount of class-based components that I had by making sure that state was organized into those stateful class components. And then I would just use those stateful class components to render a whole bunch of these pure components that just take in props and return React elements. And I still kind of do the same thing with my functions and with hooks, is that I will have hooks that are more complex, and I will have or components that are more complex that have hooks inside of them, and other ones that are purely just take in props and return DOM elements. And this is how we make a component stateful. Here we're providing an initial state to this component. So one of the differences is that with hooks in React, we can make many use states. So I can call use state 4, 5, 6 times in a component if I want to, and each one of those represents a different value that React is storing for us. With components as classes, we have one kind of state object that has a bunch of properties on it. And in this case, we have one property called count, and it stores the value 0. But we would put a list of other properties and store all of our state for this component in this one state object. And then we would change it in a slightly different way. So if we want to, this is how we would use a constructor, but with updates to the language. See, ES6 is still changing. ES6, uh, the syntax is still changing, and there's a proposal to be able to declare properties like this, where we say state equals and then give it an object. Whereas officially in JavaScript, still, this is what we would have to do to accomplish the same goal. But because we transpile our code, we get to use this today. But this is kind of what is happening behind the scenes. And so before, what we would do is we would just describe a constructor for the component. We would pass it in props. We would take those props that are passed in on the new, right? So this is actually when new gets called, React passes the props to the component. We receive those props, and we have to make sure that we call the super class, the component here, with super as well, and pass the props up the chain. So there's this kind of inheritance and component hierarchy here, which it stops at one. We don't do any more inheritance in React after this one type of inheritance. So all of our components inherit from this React component, and they all, if they have a constructor in them, they all need to call super and pass the props to that component. And then you could define default instance variables here on the class and just render those out through accessing them through this.state. Just like very similar to what we did with the props. Here we say this.props. So every class component has this.props. And here we say this.state. And every class component doesn't have to have state. But when we start to define state, the way that we would access it is with this.state. Okay. So how do we change that state? Because that's the whole point. Otherwise, we can just have props that are passed in. And in this case here, the way we pass state inside of, or the way we change state inside of a class component is through the set state call that's built into the class component. So this is, again, we only have one set state call inside class-based components because we only have one state object inside class-based components. Whereas all week or all of last week, you were using, in some cases, the word set state, but that's just because that's what we named it. So in that case, that would be a slight difference, is that in order to set state inside of a component, we just use the function provided to us. Whereas when we do the React use state call, it returns this function to us in an array that we destructure, and that's where we get that from. So slight difference. Anytime we want to change the state on a class-based component, we need to call this.setState. But we do get a bonus for this, and something that makes our lives a little bit easier. Because setState knows that the only objects we can pass to it are, or the only thing we can pass to it is objects, and those objects has keys, and those keys should represent state. We don't need to actually pass in all the state and the new state, kind of like we do before, where we spread in the existing state before we add the new state. With class-based components, this is very interesting, or sorry, very important, that it will merge all of our state changes. So if we have 2 or 3 different properties here, and we do a set state call with only one of them, the other 2 properties will remain because the merge that we do manually with hooks is done automatically for us by the set state function and by React. Okay, so that's a major difference between the 2 APIs, is that set state will do the merging for us, and use state, we have to do merging if we decide to use an object as our value. Okay. Ask me questions after if that's still unclear. I hope to go through some of these in the examples in the live coding, and also this video I will post after. So hopefully you can review this part again if you need to. So handling events is very similar. Here we have a button. It has an on click, and we pass it an increment function. This is this.increment, so it belongs to the counter class. This.increment calls this.setState, and it takes the existing state and it adds 1 to it. So here I'm passing increment to onClick. So this.increment is my reference to my function. So this isn't very different than what we would do if we just created a function inside of our component and then we pass that in as an onClick callback. We've all done that already. this is how we might do it if we need to create a function that has a whole bunch of logic on our component. Okay. I'm changing the slide. So I'm going to stop changing the slide. We're going to look at the first slide here. We're looking mainly right at the increment function. And the only difference that I'm going to make, the only change I'm going to make is to actually define this as an arrow function. Now, the reason why I'm defining that as an arrow function is because I have to actually think about the context of this inside of my class-based components. And so when I pass a function around, the way that this context works is that it will be changed depending on who calls this function. So wherever this dot increment actually gets called, that will affect the value of this inside of the increment function. And one of the ways that I can avoid that from happening, because I don't want what I want the value of this to be is this counter. I want it when I call this dot set state, I want it to be the counter's set state. And when I call this dot state here, I want it to be the state that belongs to the counter. And when I pass this dot increment to another to something to call it, and it calls that function, well, this no longer happens to be the counter. It is something else. So therefore, one of the ways I can force this value is by using an arrow function here, because arrow functions do not have the same properties as regular functions in JavaScript when it comes to handling this context. And I know we haven't had to do a lot with that lately. And again, this is one of those complexities that we do have to kind of talk about, but we'll have to learn it over time, and you'll have to get some experience with it today. But there are issues where it'll say things like, no function set state. Well, you're calling this, the value of this has been changed to something that doesn't have a set state call. So that's the error you would get. Or, no value state, or cannot call, cannot access property on null value or undefined value. Well, that means that the value of this might be undefined because we didn't bind the context correctly to the function before we passed it around. And when I say bind the context, I'm going to actually just pull up 5 approaches to binding this context. So this is this article here that's in the notes. And it says there's these patterns that we can use to solve this binding problem. And one of those ways is by using React.create class, which I don't recommend to anyone. But one of the things that React Create class did back in 2013 was it would automatically bind all the functions that are defined in it to the context of the class. So you could just use this freely. You could pass functions around freely. You didn't really have to think about it. But then when we switched to ES6 classes, because they are now vanilla JavaScript and we don't have that extra layer of React deciding what they can do, then we have to now deal with this. So one option, we can actually call a bind method on a function, pass it the context that we want it to be, or the object that we want it to be bound to, and pass that to the handler. So in my example here, it would be this.increment.bind. This would be how I bind the increment function to this class. But I could keep going, and I could see that if I use, that's actually a bad rendering. This is an arrow function. I could use an arrow function right and pass that right to the onChange call. And that actually behaves very similarly to why this arrow function change also happens to work. Is that if I did an arrow function in here, then what I'm passing to onClick is an arrow function that inherits this context of the render. So that solves that problem. There's a few other ways to do it. Right at the top in my constructor, I can actually recreate this function locally with the function bound to this context. They're very similar ideas, just again, different syntax to do the same thing. And then the way that I've decided to do it is just to declare those functions in my class using an arrow from the beginning. And then I don't have to worry about it from that point because the context is bound when the arrow function, when it's created. And so more on this topic would be, let's see, where's volume 1? We're looking for the first edition. There we go. So there's two sections on this. I'll go to the first chapter because there's this excerpt that I want to read to you. Okay, so don't read this yourself. Let me try and read it to you, and just listen to what I'm saying, because I'm going to actually provide context as I read it. So I know it's tempting to just read this, but let me read it to you. So I know that we didn't see this part, but earlier we said that this is not an author time binding, but instead it's a runtime binding. So the difference between an author time binding and a runtime binding is kind of what I was talking about when I said that the context of this will be applied when the function is actually run, compared to the context is applied when we create the function in the first place. So right now, with this logic here, I'm creating the context when I create the function. So this is a author time binding that I've created. Whereas I didn't create an author time binding here. So this function still doesn't have a binding of this. So when I pass this increment to another function to call later on, then it calls it and it uses the runtime context at that point. So that's the major difference that we need to think about is this context, is it applied at author time or runtime? Well, we can cheat it and make it author time by using things like the dot bind function or the arrow function. Okay, so but it is a runtime binding, and if we do not bind it ourselves, then it defaults to this behavior. So if it is defaulting to this runtime binding, so let's talk about it in this context here, where we're not dealing with this ourselves. It is contextual based on the conditions of the function's invocation. So here it's saying that based on where and who calls that function, this context will be different or could be different. So if I pass it to one function and it calls it, well, this context would be different than if I pass it to another function that calls it in a different way. And it's because that invocation is the calling of the function, and at runtime, it calls that function, and it chooses at that point, based on the conditions, what this context should be at that point. Okay, so it's making this decision. This binding has nothing to do with where a function is declared, unless, of course, we decide to change it with one of these approaches to solving that problem. But instead has everything to do in which the way the function is called. And so that's why we need to be careful of it. So I think that's kind of where I'm going to leave it, because, again, we don't expect to learn this context in one day. But that's my sort of, at this point, how I can try and explain that to you. So I accept that could still be confusing. Please ask me later if we want to take it from a different angle. Okay. So then we've also got this concept of LifeCycle. This is something that I really need to talk about, and I might sound quite opinionated about this, and it's because I think it's dangerous to teach LifeCycle and hooks and use effect to you all in the same context. I think that's a mistake, because I think that some people, and out there definitely online, if you see and look at blog posts, there are people that will try and teach hooks referencing these life cycle concepts. And if you hear people doing that, ignore them. Just say, I appreciate it, or just maybe listen to what they have to say, but understand that component life cycle and the use effect hook have actually very little to do with each other. And when we say, oh, I want this to only happen when the component renders the first time, that's not the same as saying, I want to do this when the component mounts necessarily. Okay, so we want to try and extract these two ideas from each other and think about them separate. So let's only think about component lifecycle in class-based components, and let's go back in time. There was no use effect, but we have this problem we need to solve, and that is we do need to, over the lifetime of a component, we do need to know about certain events that exist in its life. So here is an example where first the constructor is called when a component is created in the DOM. When it's first added to the virtual DOM, and it's the first time that React has found out about it, it will call the constructor and pass in the props, and then we'll log out this message here. So this is the first message we should see. And then the component will render. There's actually a few other things that we'll do in between, but let's just say, to keep it easy for now, it will render. And when it renders, this component returns a div, but it'll just call console log this message here. And then React says, okay, well, we've mounted a component. That means that we've added to the DOM for the first time. So we should actually let the component know that it is now completely mounted and ready to be a part of the DOM. That's what this is all about, is that, hey, your component is now in the DOM and you can do things in here that you can make us, or you're allowed to now make the assumption that your component exists within the DOM. That's what component did mount actually means. It's not necessarily like, oh, it loaded for the first time. It's like, oh, it's ready for you to manipulate. Okay. So there's also this idea that that component will be removed from the DOM at some point. And a lot of times that happens with conditional rendering. So when a component is removed from the DOM, we're actually taking it out before it removes the component from the DOM. It will call this function on the component and say, hey, heads up, we're about to take you out of the DOM. We're not going to give you any more updates. You're done. So maybe do some cleanup if you need to. Right? So clean up after yourself. This is a good place to clean up after yourself, is before the component unmounts itself. And this would be sort of the in between. The full life cycle of the component is not just when it is mounted and when it is unmounted, but also the in between. And most of the updates and most of the calls into the component happen here. Whenever the component's props change, or whenever a component's state changes, it will call component did update and pass in the previous props and the previous state from the previous render. If if something has changed, it'll call this. So we could console log either the props or the state has changed. We could check to see if the count has changed from the previous count. So is it the count that the user changed? And imagine if you had 10 or 12 different pieces of state here, then what you might have is 10 or 12 different if statements checking to see what actually changed. And based on what changed, you might need to trigger a side effect. So this is actually where your side effects might have existed, or definitely would have existed before with class-based components, is you would do something like, well, if the state count is not the same as what it is now, the count has changed. So what I should do is trigger an API call to update my backend or something like that. That would be maybe something you would do every time the count changes. Or maybe I would reset my timer. And that's kind of where you would do this. This is how we might handle those types of side effects. Okay. Everything else in here is what I showed you. So we've just added the component did update to our class. Okay, so any questions before I get into this? Because I want to show you how this translates into hooks a little bit. But for now, it's hard to kind of see why this is a problem. This looks like a single kind of use effect call, where this is like the dependency list, except with a use effect call, the dependency list is built in for us. If we say we depend on the count, then React will compare the old count to the new count and only run the effect, which would be necessarily the contents of this part here, when those things have changed. So it actually, I think overall that gives us a bit of a nicer API to work with now, because we don't have to think about this whole if prev matches current, then we know what changed. The dependency array solves this problem specifically for us, or helps us with this solution. Okay. So I'd love, which DOM am I referring to? Okay. So so I'm referring to the document object model that exists in the browser. And that is all that's happening when we return DOM elements here, or sorry, I guess these are called React elements, even though they look a lot like HTML. All components return React elements, or null maybe, or maybe an array of elements, but basically the same thing. They're all just React elements. And what the React DOM library does is it converts this tree of elements that are created by React into the actual document object model that's in the browser. So that's what creates the divs. This div exists in the document object model, and component did mount means that the component has this div has now been added to the DOM, where we expect it to be underneath whatever renders this mounting example component. So that's what component did mount means, is that we've added these elements that have been rendered by this component to the DOM. Does that answer your question, Jeremy?
Yeah. So because there's also like a virtual DOM with React, right? So it's the browser DOM that you're talking about, basically.
Yeah, so I'm talking about the browser DOM, but the whole virtual DOM thing is really more about trying to make updates fast. And so let's say that we make a change in React that only causes a very one component to actually change, but we re-render most of our application. So we render most of our application, but really only one small component changed, and all it was an update to a counter that goes from 0 to 1. And that change really only requires a piece of text within the entire DOM to change ultimately, right? So when that piece of text changes, really what we want to do is find that if we were doing it in jQuery, we would want to find the DOM node with that counter text and then add one to it or change its value to represent that it has a one now. That's something that React does for us. It goes and it finds that DOM node and it goes and it changes the text, but it doesn't go and re-render every other DOM element or change every other DOM element or recreate the DOM every time. And it uses the virtual DOM as a way to determine whether or not what changes have been made, so that it can go and actually make those changes imperatively to the DOM. So I don't know. Should I keep going on that? Does that make sense? That yes, there is a virtual DOM. Yes, React is creating a virtual DOM, but it is only creating a virtual DOM because it's a faster way to find out what part of the DOM has changed so that it can go and make the calls to the actual DOM to make the changes that need to be made, like changing that one piece of text, for example, or applying a different style to a tag, or removing a class name or whatever it is.
Okay, thanks.
Mhm. Remember, React is a declarative way of managing the DOM. jQuery is the imperative way of managing the DOM. That's one of the major ways that they differ. Is that um, we don't actually provide the instructions that make the DOM changes. React provides the instructions that make the DOM changes. We provide a description declaratively of what we want the DOM to look like, and that's how React makes its decisions about what it needs to change for us. So it's kind of a different approach, and I definitely recommend maybe now that you've played with React a little bit, um, to go back to the. Let's see if I can find it. I'm just looking at up some material. Ah, okay, yeah, I found it. No, that's not it. Okay, so I know this is back on week 6, day 5, and it really is just sort of talking a little bit about sort of what the differences are with React. This might be worth reading now again when I'm talking about things like React is declarative, whereas jQuery is imperative. It sort of tries to talk about that, and it might be worth um, going back to some of these things and even comparing the code for the jQuery image search, which has some JavaScript, which has these ideas of components, but those components really just they return things that look like JS. Like this is how I might build the same kind of an idea of components using jQuery, but at the end of the day, I still need to um, uh, change these elements, right? So here in this case, it's going to re-render this whole thing for me. It's going to replace this whole article every time. whereas React would be smart about it and actually go through and figure out which stuff has actually changed. So a bit of review might be worth on this topic. Okay. Anything else? Any other questions before we take a break?
I have a question about the last slide. The one was before the one. Yeah.
Yep.
No, not this one. This one here. Yeah. No, sorry, the last one. Yeah, this one here.
Hmm.
So in the increment function, there is then arrow function and this. Is this going to behave the same way as it would be just a normal function without the arrow function?
That's a good. Yes,
I mean,
good question. Here, stay on for a second. I'll just clarify. So when we go back here, the major difference between these two is the arrow function, right? Is this what you're
yeah,
talking about?
yeah.
Yeah. So this is a regular function, and this regular function has no binding built into it. There's no. It is. It is no. The context of this is not decided for this function at this point when it's declared here. Whereas with the arrow function, that behavior changes. One of the major differences. So I know we teach arrow functions are a nice syntax for functions in JavaScript to make it easier. We don't have to type as much. But really, the major change, the thing that actually really impacts us more than anything, is that arrow functions, their value of this will be created and bound to the function here at this point. And so we know that this arrow function is created inside of this class. And so this arrow function is going to have a this context that is for this class instance. It's it belongs to, and that's so it is very different, these two things. Okay. So here, when you ask, this arrow function, if we change that to a regular function, well, then we have this problem where it will bind the function as soon as it gets called by the on-click handler. It will have the wrong context of this. It won't have a set state available to us. And then we'll get an error in the browser. And I'll try and recreate some of these when we go through, and I'll show you the difference in the code example of when we make this a regular function, when we make it an arrow function, and then we'll go look at what the value of this is in both cases and try and see how that actually differs. Does that make sense?
Yeah, it does.
Okay.
I mean, we had similar examples in Compass, but they were not really explained well. So I would like to clarify like how they work.
For sure. Yeah. And actually, the best resource is really just to read this link here and read this. This article is a good one on the topic, I think.
Okay.
Kind of goes into more detail. It actually has this flow chart here. So, and some examples. Definitely worth it. What we'll do is we won't code quite yet. We'll take a break. When we come back, we're gonna work on this chat app, and this happens to be the design for the app. It is a app. There's an application component, a room list component, a room component, a name, message input, and message list component. So this is kind of a diagram that I would use to describe to someone else. It says this is sort of what we're going to build now. So I'm going to leave this up while we take our break. If you can, at some point when you get back, while you're waiting for other people to come in, read it, try and make sense of it, and then when we come back, we'll talk about the app before we write any code and see if we can understand how important this type of a diagram can be. All right. So yeah, let's come back in about 10 minutes. Thank you. How do we know when enough people are here to start? Thank you. Here, good. Maybe a few more here's from the no video folks. I don't mind the no video. Just okay, cool, great. I think we're pretty good. Okay, no problem. Thanks, Jeremy. So I left this up on the screen through the break, and I maybe some people had a chance to look at it, maybe not. I'm going to come back to it. Before we come to this diagram, I'm going to share with you another diagram that I used to use for the my original day one React lecture, and I guess day two in this case. Is this familiar? This is kind of like a reimagining of the Tweeter app that you built in week 4, I believe. And so in week 4, you build an app that you could type into an input field. It would give you immediate feedback on the number of characters. If you tried to post a tweet and it was too short or too long, it would give you back error feedback. It would, if you tweeted successfully, it would add your tweet to a list and render that in the underneath. So this is sort of a tweeter made in React, and the whole point of this slide is really just to say, well, when I start an app from scratch, I don't just start writing React code. I start with a wireframe and I create a design, and then I write the HTML, and then I write the React for it. So I kind of don't just jump right into it. But really, what I want to do is once I have that HTML, and so I could have the full. Actually, I'll show you. If I have the whole HTML for that tweeter, which anyone's capable of creating here. It's got an article with a header and an actual tweet. So what I do is I take that and then I convert that into React components. So this is sort of where I start from when I'm in React world, is components or HTML, and I want to create components. I want to take these things, split them up into different kind of ideas or single sets of responsibility, break them up into components. And this is what we're really talking about here, is it's a React application is a tree of these components. So in my Tweeter app, I might have a root application component that has a child that's the header and the main section. And the main section could have a list of posts, or in this case, a series of posts, a post series. Each post within a post series, which is really just a mapped list. And you've done that now. You've mapped over an array of objects and converted that into an array of components instead. Those components are post components. You have n number of those, one for each tweet in your list, let's say. So, actually, this is like the whole component lifecycle, or close to it. All these, when you're mounting, these are the components that get called, or the functions that get called. When you're updating, these are the functions that get called. And when you're unmounting, this is the function that gets called. So the ones we really care about today: component will mount, component will up, component did update. That's actually wrong. I should fix that. Okay, these are old anyways. My point, though, is I want to get to this here. And I want to talk about this in terms of Tweeter. If I came to you and said, hey, I want you to take Tweeter and convert it and build a React app, then you could go and actually start to build out some components, add some state, make some event handlers. Another thing you could do is actually start to design the app and think about, what types of components do I need, and what state do those components have, and when does state need to be passed down to those components as props to give access to them. And so this might be an example of my Tweeter app, where at the very top I've got an array of posts. That's all the tweets that I see in that list. And the header component doesn't actually care about the array of posts, but it does care about being able to add a new post to that array. So when we click the post button, what it would do is call a function called onPost, and it would include the data that's necessary in order to create a post. That data happens to be the content that's currently typed into an input field. There we could show an error. So maybe we have state about an error, or whether or not the header is visible or not, let's say. Over here, we might pass those posts down to a post series component, so it can map over them and render a post for each one. And each post will have its own props, and those props will be things like content and date and likes and the user object itself. So this is kind of what we're talking about here, is how do we describe a React UI as a combination of components with the state and the props that they receive. So coming back to this now, I'd like to ask if anyone's willing to share anything that they can kind of derive about our application, the one we're trying to build here. Can you tell me anything about that application based on the diagram that I'm sharing with you here? How many components are there? 6. Yeah. So 6 components. So that I think we can understand on the diagram at least what's meant to represent a specific component. So that should map pretty well. Could anyone share with me maybe some of the state that exists on one component? I know that one's a little trickier because what's state, what's props, but I have split it up. I've split up state and props for each component. Props being the things that are passed from the parent, whereas state is things internal to that component. So what's a good example of state somewhere in the application? Okay. Yeah. So room list has a rooms array, and that stores a list of all of the rooms that you could join. So amount of people in the rooms, I would say right now we might not have that state. I don't see that anywhere here. That might be a requirement. I don't think it is for this one. We're not necessarily counting. Um, but what we can do is, so the first one here was rooms. So there is, when we load up the room component, we want to actually make an HTTP request. So that's actually what this is signifying, is that the room list component has a side effect. And the side effect is it will go off and ask a server to give it a list of the rooms that are available for this application. And when it receives that list, it'll store that array of rooms in this room component so that it can render those rooms. Right. So the room list here, it could have a list of rooms. We could take that room list up to the top, put it in the application up here, and pass it down. And then every time we update the rooms, we also have to call up to this one and say, replace those rooms with these new ones. So it might be a little easier to make that state part of the room list component, because actually we don't need to show a list of rooms anywhere else in this app. We only need to show the list of rooms in the room list component. Everything else is about a specific room chosen. Okay. So could someone maybe tell me another place where state exists? How do we keep track of which room we're currently in? Yeah, so track the room, pass down from props. So here, the application will know what room we're in. And when we select one of the rooms in this list, we'll call set room with the room value. And that's going to go up to the application. And the application is going to set the state internally. And it's going to change this value of room to whatever was selected in that list. So this is a list of room names. We pass that name back up using this set room action that's passed down as a prop. So these lighter, these light opacity, these are all props passed down from the parent. So the application has a room state, and it passes the room state down to the room component. The room component then also has a side effect, let's say, or actually, the application has a single WebSocket connection at the top. And so when the application loads up, it's going to make a connection to the WebSocket server. And every time it changes the room, it's going to connect to a different, actually switch rooms, send message to the WebSocket server saying, hey, I want to switch to this other room instead. It'll stay connected to the socket server, but this component here, it will continue to change what it actually displays. And the way that it does that is it makes an HTTP request. Anytime the room is changed, the state is passed down to the room component. The room is changed. We want to do a request to get the messages for that room. Right? Anytime we go and change the room state, then we want our room component to go and ask our server for the messages that exist for that room. And that way we get to see what messages were posted before we entered the room, the ones that we weren't there for. Those messages will be stored locally inside of the room. And if the room changes, then yes, we will go and download new messages and store those here. But when we change room again, we'll just go and get all the messages from that room. So to the user, it looks like we never lose track of messages from the rooms, but really it's just that we're continuously going to be requesting for them every time we change a room. We're going to get the latest list of messages. Then a room is going to have the ability to you can change the name, you can set your username, and that goes all the way up through a set name action. Set name action is passed from the application down because that's where the state exists at the root. Set name will change that state. We pass it down to application, and the room doesn't actually change it specifically. It passes it to a component that knows how to have an input field that's controlled, right? So this is just this is the local name. This is the controlled input state. So when I'm typing to my input field, it will keep track of that value here. This value is unchanged until I hit enter. When I hit enter, it calls set name with whatever value was in the input field and passes that up to room all the way up to application, and now my name has changed. So that's kind of how that data flow works. Name is at the root. We pass set name. We pass set name. We type. It changes the local name variable, which is different. Hit enter. It calls set name all the way up here and changes the value. And the same thing is similar for the messages, except send message doesn't come down from the application. It comes just from the root room here. And so send messages takes in the message we've currently typed in and pressed enter, passes that back up to the room. The room will then send that over the WebSocket to all of the other, or to the WebSocket server, and then WebSocket server will send a response or an update to everyone in the chat room. Okay. So, any questions? I know we're gonna. It's a lot, right? But what I really want to get out of this is just that we can diagram and talk about these things. They don't have to exist just as code and just as only small pieces we keep in memory, but instead we can diagram this out. And you can do it any way you want. As you saw, this is a different way to do that. And if I bring up another, I think I've got another one here that I've been working on. Oh, that's a different app. Never mind. Let's see. Oh, here it is. So this one is not done yet, but all these components exist in here, and these are all the different props that are passed to these components. And then I would connect all these together and show the parent-child relationships. So I do this pretty consistently. Mine tend to be prettier than they need to be in the sense that I create them for you all to consume them and look at them. Whereas when you're doing this on your own team, it's okay to do this on a whiteboard and take a picture, or on a piece of paper, or using draw.io. You don't need to go all in like I did here. And especially like this. This is just presenting to you. So we can do this. You can do this in Scheduler. You can do this with your final project. And I just want you to think about how do we actually conceive of these apps before we start writing the code for them. I'm going to head over to this. Actually, I'll just show you quickly. This app ultimately does exist for Tweeter. The client is here. Within our JS, we have an app component. This app component has a state called posts. It also has a function called onNewPost that it can pass down to the header. The main gets past all those post props. And it continues and passes them down to a post series component. And the post series component takes them in, maps over them, and for each post in the list, it creates a post component passing in those props to each one. So that's sort of what I try to describe on the in that diagram. Now, you're welcome to go and look at this code. I'll just paste this right in the channel. And yeah, if you wanted to reference this, because it has all class-based components, so it would give you an idea of some of the stuff that we're talking about here. Okay, so what I want to do is I want to go into the classes notes. So this is the notes for this repository, for this project here. And I want to clone this. And so this app, I'm going to just npm install, and then I'll open it up in, I guess I probably should open it up in code first and then install so I can show you stuff while I'm installing. But I'll learn that for next time. I'll just review these notes to make sure I didn't miss anything that I wanted to say. Cool. I think I went through it all. So I will open this up in code. And I'll get this project running first. So I really like to have a completed project that I clone. I like to install the dependencies, and I like to show it to you finished, because I think that building up an app from scratch is really nice. And I tend to do that even in some cases where the app is small enough that we can actually fit the whole thing into an hour or 45 minutes or whatever. But I think it's hard to know what the app is going to be like at the end, and I think it's hard to understand what we're doing if we haven't seen the app beforehand. So I like to at least run this thing and show you what we're actually working towards. And there's two pieces to this app. There's a server and there's a client. And the server I will just run in another. Okay. 3,000. Okay. Oh, there it is. So this is the app loaded up. I'll try and make it quite a bit bigger. And this is the room list at the top. Has everyone kind of realized again, still, maybe I brought it up last time, everything we do is a list. Everything we build is pretty much a list anyways. We build menus all day, Netflix style lists. Sometimes they're simpler than this, but even if they have movie covers, they're still just lists, right? So here's this list, and when I choose one of these, it will give me the option to choose my name. And we can see the output here in my server. Oops. Someone has connected to this server. Yeah, it was me. And they joined the room 1. So that message has been sent to the server when I clicked on the 1 room to join. Now what I'll do is I'll put my name in there. And I can see that when I pressed enter, it didn't do anything. Or before I pressed enter, here, I typed stuff in, and until I pressed enter, it didn't do anything. But once I pressed enter, it called set name, and it passed that value from the input field to the WebSocket server so that it set the name on the server as well. And so now my name here is shared across these rooms. As I join different rooms, that's what I'm doing here. I'm clicking and joining these different rooms. My name is retained across these because it's just one name for one connection to the socket server. But if I want, I can go in here and say, hey, how is it going? Anyone around? So this is the message I've typed. If I look at my socket server, I can see I joined rooms over and over and over, just kept clicking them. And then when I finally settled on room number 1, I added a new message, and the message was, "Hey, how's it going?" And then the socket server broadcast that message to no clients. So it said, well, there's no one else connected, so I'm not going to send this to anyone else. And you know about this message already, so I don't need to send it to you. Does that make sense? Okay. So this is going to rebroadcast our messages. If I decide to load this up again in another tab, or let's say like so, then this user has not joined yet. They can join a room. We can see that it actually has the message, even though I haven't joined this room before. And that's because we've made a request to the server to get those messages when we load it up. And the only thing that really has happened as far as the WebSockets are concerned is that that new user has joined a room, but we don't know who they are yet. They can put in a name. So now we've set the name on this other client to Malloy. And so as we look at these two and type the message, we can see this person has responded. This person gets the message. And the difference is one person sent the message, "Hey, I'm here now." But now it says that we broadcast to one client because now it said, oh, there's more than one person connected other than the person sending the message. I'm going to loop through all those clients and send them a message over a socket that says they have got a new message for the room they're in. Okay. And that is pretty much what this app is able to do. If I go to another room and I switch back and forth, every time I do this, if we look at my inspector and my network tab in my inspector, every time I switch back and forth between these rooms, we're making an HTTP request. This one is saying, I want to get the messages for room number 2. And if I click 3, it says, I want the messages for room number 3. And room number 3 has no messages. And room number 2 has one message that says, hey, here. Whereas room number 1 has those 2 messages, one from Susan, one from Malloy. Okay. So let's go back quickly to this diagram and think about it again. When I load the app, I have no name, I have no room. It does automatically render the room list, so it will make a request. Let's see that request. When I load this thing up the first time, here's my request to rooms, and we get back a list 1, 2, 3, 4. So that's what's happening right here. Room list goes off, HTTP request comes back, rooms array is set to 1, 2, 3, 4. That's what it renders up here. We choose one of the rooms. It makes the call messages. Makes the messages API call and tells it what room it cares about. That's what's happening right here. It gets those messages and it replaces this array with those messages. Whenever someone types in a message and hits enter, it updates this array locally and it sends a message to the WebSocket server that says, I've created a new message and here's the contents. And then that message comes back into all the clients, and those clients will, you can see here in their WebSockets, this is the client log for WebSockets. I'm going to the WebSockets filter under the network tab, choosing the WebSocket connection, and then I'm able to look at the messages that are sent out and the ones that come in as well from someone else. That's the red arrow. This has come in from someone else. This has come in from the socket server, and it has been rendered by my React app here. Okay. So is any questions about what I've gone over here? Because I want to make sure that it's really clear what the end goal is before I go and start rewriting some of these components to do the things that we talked about. Okay. So I'm not going to rewrite every component because some of them are really boring, and there's no point in you sitting here watching me uh, retype class, extends component, render, return, all that stuff over and over and over again. So what I really want to focus on is the different things that we need to do in this application. And I want to talk about how we're actually defining uh, what we have here in this diagram through code. So let's talk about the application and its two pieces of state and the WebSocket connection that it makes at the beginning. So here we define the state. This is again pretty new syntax because we're using classes. This is our initial or default state, and the equivalent if we were using a hook would be something like and then this object is our default object. So we would put that here. And so if I wanted to kind of do the same thing in a functional component, then I would call useState, give it the default, and have access to a state variable inside my scope. Slightly different here. We're affecting an instance variable called state. Give it default values still. That's not different. We still want to give default values to every single piece of state that we have in all of our components. This thing here will only render the room conditionally when a socket exists and a room has been chosen. I think that makes sense. That we only render this room component when we've actually chosen a room, because that is a dependency. We need to know what room we've chosen so that we can go and get the messages for that room and then render them back to the user. So here we'll say, don't bother loading this component until the socket has been created and we have joined a room. Okay. So here, how does a socket get created? It happens in this function right here. We want to create the socket connection one time when the user loads the application in this case, and then we'll use that same socket and we'll keep sending messages to change our state within the chat rooms and which messages we've sent. So I've created an environment variable here because it's important that we don't hard code our URLs. I'm not going to say WS. I'm not going to do this in my app. If anyone thinks that we should be able to do this and is confused why we shouldn't do this, then please let me know. But I always configure my URLs because when I go into production, my WebSocket URL might be different than it is in development. And so I want to be able to configure that without changing any of this code. So just imagine that this value is defined, and it is right here. This is the connection that I'm going to make to the server. Okay. So that's all that's happening. I'm basically just new WebSocket. Here's the location of that WebSocket server. But I use an environment variable because I'm being responsible. This socket, this dot socket is an instance variable. It's kind of like when we saw now we don't need this because we have it being declared here. And we could say socket, we'll declare the variable up here and use it down here. But the idea is that we just create an instance variable. And the fastest way I know to do that is just this dot socket. It's going to be existing within this class, referenced through this variable, and it will have a link to that socket that we've created. Component did mount only gets called when the component is mounted the first time, or actually when the component is mounted it is called. So even if a component gets unmounted and then remounted, it will be called in that case. So sometimes we can unmount and remount components over and over. This will continue to get called. In this case, we only want this to get called when the application mounts, which happens to be the root of our app. So this should only get called one time. Creates the connection. And then we also need to think about what happens when we close our application. Do we clean up that connection as well? And I think in this case we should disconnect from the socket when we when we close our connection, when we remove that component. Okay. What if we declare component did mount with the arrow function? So I never do this because it's not necessary. My understanding and how I've experienced this is that because component did mount is called by React, um, they can actually call it, like, technically React could do this. They could take the function and bind it to my component for me and then call it. Therefore, all of the context inside of this component would be set correctly. So we don't have to do this uh, for the built-in methods. We don't need to use arrow functions to work with this context. Uh, I don't. I've never tried doing it. I don't know if there's an adverse effect in doing it because I've never had to. So if you try it out and it doesn't work, let me know. But for me, I would just create these. I would just not even bother using arrow functions here because it is not necessary for these built-in methods. It's only necessary for methods like this here, where I am. This is my own method, and this one here has no binding. And the way that I'm dealing with it in this app is one of the options is to bind it whenever I pass it in to something that's going to use it. So here with the set name, which is just a function that can go and call set state, same with join room. Those things could be passed like so, but in that case, then I would have to switch them up here and make them arrow functions. But these are not built in by these are not React provided. These are ones I have, so that's why I need to manage the context of this myself. I hope that makes things a bit more clear. Yeah, not necessary for these. It'll still access that properly. I'm going to be interchanging and using different ways of binding this context throughout, but that's only because I want to be showing you how many are available. My recommendation to all of you is to choose one method and go with it. Either always use the arrow functions for your instance methods, or bind when you pass them in, or bind in the constructor, whatever way you decide that you like the most. Try and stay pretty consistent with that. But for me, I want to show you as many options as are available. So, what are we doing? Yeah. So with this component, let's that's not that interesting actually. I think the more interesting one might be this room list. So let's just get rid of this. Okay. So this room list, it has the state of all the rooms that we have available to us. That's what we're showing up at the top here. And we also show a button called leave, so that if we are in a room, oh, I may have broken it now. We'll come back to that. And actually, let me close one of these. I only need one to start off. I need two when I test all the functionality at the end, but I only need one to start off. Oh, okay. I think I broke it, right? So what I did is, here's one of the errors. This .set state is not a function. This .set state. So it's saying here, I'm trying to call join room. When I click on that button, it's calling this .set state, and it says this .set state is not a function. First thing I want to do in this case, let's find out what this is then, right? Because if this .set state is not a function, then chances are the value of this is incorrect, because if it was correct, then since this is a component, set state should exist and be a function. So let's just see what it is instead. We load this up, we go look at our console, we press explode, and we see that this is what we're getting out. This is actually what we're what is this? Does anyone know what this thing is? The thing that I console logged just now? I could probably bring this up and make and it if we look at this if we look at it very closely and say room and select room, and then we look at it here and we see, is there anything that matches that schema of room and set room? Or sorry, this says select room. I may have named it wrong. I think this select room. So basically, what this is here is this happens to be the props object, the one for the room component. And and the way we can sort of backtrack is we can say, well, who calls join room? Because we said, actually, no, wait, I didn't. Yeah, I did. This should be set room or select room. I think what I'll do in the future is actually update my. I'll update this instead. Make it say select room. But the idea is here by room list, I'm passing in these two props. That matches the structure of this, which is what I'm console logging. So when I console log this, and I get back room and select room, which happens to be the props for room list, then what that tells me is when the room list component is calling select room, the value of this is getting set incorrectly. So we go into room and we say, where is it calling select room? I think it's the room list. It's on or choose room. That's the one. Yeah, I'll figure this out. Okay, so it'd be like something like this. What this is a list of all the rooms. Those rooms we'll get them from the API. Right now it's an empty list. When we loop over that list, we create a new component, a list item for each room. That list item has a button, and when we click that button, we call this.props.select room with the name of the room. Okay? That's going to set the state at the top of our component. That's going to set this room state when we call select room down in the room list component. So when we call select room, we go back up. This is the function that's being called. The value of room is being passed in, I believe. See, the value 1 is being passed in. So we call select room with 1. But the issue is that this context matches. It's actually this object here. Is anyone, or are we able to make this connection that this.props inside of the room list has a room and a select room property? Those happen to be the properties that comprise of the object when we console log this. And the reason why this has the value of this.props from this other component is because select room was called through this. And so at runtime, the binding is applied to select room, and it's depending on how it was called. And it was called through this object called this.props, which has room and select room in it. So when we go into the select room or this join room call and actually console log this out, well, the reason it doesn't have set state is because it is this thing. And the reason it is this thing is because this function is called through this props object. And that's when the runtime binding happens, right here when this gets called. And so the way we avoid this is by ensuring that we have a bound version of this function. When we run this now and we click on it, it doesn't complain anymore because now this context was previously bound to the component that it was in before it was ever passed to anything else in the first place. Okay. So that's kind of like an example of what it looks like when we don't bind properly, or when we don't use an arrow function to do the binding, or when we don't use one of our 5 patterns for binding this context, is that the value of this isn't what we expect it is. And the first thing you should always do is console log it and see what it is, and see if it's familiar, and see if it's undefined, or see if it looks like it's some props from some component that's calling it. That's kind of how I backtrack and debug those issues, because you're going to run into them. It's something we forget to do when we use class-based components. All right. So what I want to do in this room list is I want to make it so that, and actually I'm curious here. Why is, oops. Why is this rendering anything right now? Oh, there we go. I don't know. So this is the start. This is what we're going to start with. Is right now it's just this list at the top. And this list is like, I don't think I need to write all this stuff, because this is all the same React that you've been writing up until this point. The only real difference is we're accessing props through the props instance method or instance variable instead. So here what I'm going to do is create a list of rooms, and I'm going to render my list of rooms and then one item at the end that is a leave button. So it's however many number of rooms plus a button called leave, and all of that is just a list. This is my list. So what I need to do is I need to populate this list of rooms that starts as an empty array. I need to populate it with a list of rooms from my API server. So I'm going to, I think it's, okay. Yep. So I'm going to go to make my request to localhost port 8080. But because I've got a proxy set up, I should just be able to make the request to /rooms. And what it will give me back is an array of room names. That's what the server will respond with. When do I want to make this request? When do I want to determine what rooms are available? My application always renders the room list. It tells it initially that the room is empty, or that no room is chosen, because it uses an empty string here. It provides a function that allows us to change the room once it's actually selected. But when do we want to determine what rooms are available to us? When do we make that API request? As soon as the main component renders, okay. So do we mean up here? Okay. Well, I would say this component will render, and it will make a WebSocket connection as soon as it renders. But we don't necessarily need it to load the rooms. This doesn't need to know anything about the rooms. So if we wanted to, we could say rooms, empty array. When we load up this component, which you're right, when this, it is not necessarily the main component, but I would say when the room list component renders is when we want to get the list of rooms. But if we were to take a different approach, we might move that logic into the application and say axios.get rooms then here's my response from Axios console log response.data. Just going to make sure that I load this properly every time I here it is coming from the application.js. We can see this is what logged it right here. So that's how I would do this if I wanted my application to know about rooms and be the source of that state. And then what I would do is pass those rooms down to my room list. See, this .state.rooms down to my room list. And then this thing here doesn't need its own state. And instead we can say this .props.rooms. Right? So this would be a way. Oh, the last thing I need to do is make sure I set that state when I actually finish here. So set this .set state. And the object that I pass in okay, so here I'm going to call, this is again something new now. This .set state, I pass in the rooms. I give it the array of room names. This rooms, I'm not adding name or room to this. I don't have to say React does that for me with this function here. React does this for me. Don't need that. All I'm doing is changing the rooms. Name and room will stay the same. Now, this works. But there isn't actually a reason to have the rooms available at this level because nothing else needs them. So I would say that this code could be brought down into the room list component. So let's go back and actually make that refactor now. We'll take the state out of application and we'll put it into the room list component. The room list component doesn't actually have state for name and room, so we'll take that out. But it does make this request to Axios. So when the component mounts, when that's complete, we will make our request to get the rooms. We'll take the data and we will update this component. And then we want to make sure that this component state reflects that. And we can remove the Axios call and that state from here. So we're now at the point where we make the XHR request, get the rooms, the response comes back, and we're loading that up into the room list component. Is that kind of clear what we did there? Any questions about that process for doing API requests in a component? Let me show you what that looks like in Tweeter. Oops. Maybe something like this. When the component mounts, we call this.load. This.load is a function that's instanced to this because we might want to load after every post as well. And so here's the logic which says, I'm going to post a message. Then when that response comes back, I will load up all the messages again. That's what we did with Tweeter, right? So whenever the component mounts, we also want to load up all the messages. So this.load is really just a helper function that knows how to make an API request. And when that API request is resolved, we get the data and we set the state. This API wrapper, it's nothing special. It's just a little wrapper around the fetch API. So very similar to Axios, same kind of idea. I've just kind of hidden it behind this wrapper. Didn't use Axios for this project. That's not really relevant. The point here is when the component mounts, we might need to make our side effect call at that point. Okay. Any other questions about this or any questions? As soon as, yeah. We're almost done. Almost done. Okay. So the room itself is pretty complex. And that's kind of where I want to wrap up the day. And I want to go through this a little bit. So I'm going to let's see. Yeah, okay, I think this is a good place to go. So we've already done this here, this option where we're actually loading up a request, or every time we go into into a different room, we're loading the messages from that room. And if we look at our network tab, we can see that every change here does get those messages. Okay. And the responsibility for this lies, well, whenever the component mounts, that's one thing, right? So if the component mounting is really just, okay, the room is now mounted, but now I'm switching between these, and that room doesn't get unmounted in this case. That room component is still mounted. It's just that the props being passed to it will be different. The props being the name of the room is different. So every time I click on that, it changes and gives it a different room name, but it doesn't actually unmount it in any of those cases. So here, this only works the first time. And when we load the component for the first time, we do want to grab its prop, figure out what room it's in, get the messages for those rooms, get that data back, and then set the state locally. And then every time this component updates, what do we actually care about that room? We care about the room changing because we have a side effect that depends on that room changing, right? Every time we send a new room prop, we want to make another request to get messages for that room. And so here, every time component did update gets called, it'll pass us the existing room and say, hey, this is the room that was here last time I rendered. And now this is the room now. And if they're different, then what we want to do is make an Axios request again at that point to replace our messages with the messages for the new room prop. So this is how we update the state based on this is how we do an Axios call that depends on changing props. We use the component update LifeCycle method to pay attention to that room value that's passed in, determine when it changes, and then make our side effect when it changes. And when it changes, we'll get rid of that one too. Okay. So that's all kind of stuff that we've now done. Axios requests, Axios request update. So this is similar to saying, when the room changes, if room is not equal to null, then do this side effect with the room. This is how we handle the same type of a responsibility when we use functional React and function components and hooks, that we depend on this room value changing. When this value is no longer the same, check to make sure it's not null, and then make our side effect. This gets called every single time this component renders. We can make that same type of a dependency check manually ourselves. We can check to see if it's different or not, or if it's not null, and then we can make our Axios request. So this is kind of how we handle that. And the cool thing about useEffect, and I want us to notice this, is that with useEffect, this will get run after every render, right? It's not when it mounts, it's not when it unmounts, it's not when it updates, it's after every render. useEffect will be triggered. That's an important distinction, because what that means is that here with the class-based component, I have to Axios request here when it mounts, because it doesn't call update on the first time, only every time after that. So I need to actually have this same logic here in two different places. Whereas with hooks, I only have to have that logic in one place. This is actually one of the benefits that a lot of people talk about, is that without hooks, this code that is actually related exists in two places. And even if I got maybe a bit more organized and put them next to each other, they're still in two different functions, even though they're meant to do kind of the same thing for me. So this is an example of how we can clean things up and make things a bit nicer using hooks. Okay. So we've got this issue now in here. If I click one, it goes and it loads. And if I try and set my name, and I think type a message, none of this is getting sent to my WebSocket server. Let's see. I think. Yeah. So we need to hook that up now. So if we hook this up to our WebSocket server, we've already made the connection. That happens up here in the application component. This socket exists. We want one for the application. And then as we join different rooms, we want to send messages to the server, things like set the name, join the room, leave the room, that type of thing. So we're passing this socket down to the room component, and it has access to it just like the application does. It can say, well, the room can say this.props.socket and send messages that way. We're going to see that here. That whenever I call send locally here, it's going to actually take that socket that was passed down to this component and send a stringified version of whatever data is sent in. Because we have to stringify everything on WebSockets because just like HTTP, there are no JavaScript objects. Everything's a string. So when we send a message over the terminal or over the server, this has to be sent as a string. So that's why we're stringifying it every time. I see here. Okay, this is kind of like more where I wanted to leave it because that had an update still. So I go in here, and it's still updating this locally, but we're not getting those messages. Okay, that's better. No messages here. And what we'll do is we'll add some of those things that we need to do when they need to be done. So when do we need to actually tell the WebSocket server that we've joined or that we've changed our name? When does that happen? So we'll go back to the app. I'll reload this. I don't need to tell the WebSocket server yet that I've changed my name and I'm interacting with the app, but I haven't had to tell it yet. I still haven't had to tell it. Although I've typed my name into the input field, I still haven't had to tell the WebSocket server yet. And only until I press enter here, that's when I press enter, that's when I want to tell the WebSocket server that my name is Susan. So we find the point in here, name. When we call set name, it's going to call this.props.setName. This.props.setName is coming here from the WebSocket or from the application root component. So this is the thing actually changing the name locally, but there's nothing in this flow yet that sends a socket message to the server. So we want to go in here and say, well, whenever you change your name, like here, for example, we also want to send a message to the socket server. And we want that message to have a type, change name, with a value of name that's just taken the same one here that's passed in. So this send function isn't built in, but that's just created by me here. And I could just as easily take this thing here and say, well, I like making my life hard. So instead what I'll do is I'll write all that every time, right? But I've just created this send helper that takes in data and knows how to send it to the socket. So that's what I'm going to stick with. Now, when I go and I make this, still don't need to send it. But then when I look at my WebSocket here and I actually hit enter, that's when I've sent the socket message to the server. Okay. So the next thing I need to do is make it so that when I type in a message, hey, I'm back. Now, when I press enter, I want it to send a message as well. That's the same thing. Same with the message, the set name. I need to, at some point in here, send a message to the server. And I think what I do for that one is just new message. That's what I'm going to say, is new message with a message that has a string. So let's find that. Where do I make my updates? Well, send message is a local instance function. It gets passed down to message input. So it looks like message input here is a controlled input. It receives, or it has a state for the currently typed message, but only when we press enter, then it will send the message and reset our local state back. So here, send message gets called. We come back up. Send message receives the message. Here's where we actually update the local storage and say, take all the existing messages and add the new one to the end of the list. And what we want to do here is also this dot send with type being new message and the message being equivalent to whatever is just passed in here. That's all we need to pass to it. So when I go in and I join and I say, this should now work. And I look at my WebSockets and I see, yes, I sent a message, and I can see, oh, got a bit of an error here. Failed to receive frame. Error shouldn't add a message if not in a room. So yes, I'm able to send messages to the socket server. Yes, I'm able to change my name. But in order for this to work, the server says I need to be in a room first. So this is sort of the final thing that we need to really think about is joining and leaving these rooms. So when I click on one of these things, I want it to make the request, or I want it to send this socket message that says join room, actually, and they look like this. Join room with the room name. I want to send that, but I want to send, when do I need to send that? When do I need to send the join room message? After you click the room in the room list. Exactly. Yeah. Well, so exactly. But I would say that when I click this name in the room list, this is actually a really important point because there is a difference between events that are triggered based on me clicking and events that are triggered based on the dependency on their data changing. So I would say in this case, I've intentionally set it up so that when my room changes, the room here, the room state changes, I want to be listening to that value change. So whenever I'm inside of my room here, not only do I want to receive the latest list of messages every time my room changes, but I probably also want to join this room. So here, when I either see, you have to do this every time. Either when I mount the first time, I need to get the list of messages and join the room. And then also every time the room value changes, I also need to get the messages and join that room. So this is a dependency on the room value changing. And when the room value changes, these are the side effects that I want to trigger. So now I should get that message going through. On my WebSocket, when I click one of these, it joins the room. I can put my name in, and hopefully I don't get that error, and it posts it just fine. Yes, it didn't give me that error anymore because now I'm joining a room. The last step is when I click this button here, I want it to leave the room. And so I'm going to just make it so that every time, actually, no, I don't need to do that specifically because simply changing to an empty room string I'm just changing the room here, and I change the room the same if I click on this. It just doesn't give it name 1, 2, 3, 4. It gives it an empty string, and that's how it knows the difference. I think here is where I just want to make sure that if for any reason this room component goes away, I want my user to leave the room that they're in. So this is where we deal with unmounting. And this is kind of a side effect being cleaned up. The side effect is that we had joined a room, and the side effect we need to clean up is we need to remove ourselves from that room before this component unmounts. And that's how we might do that. We don't need to disconnect from the WebSocket every time we leave a room because we want to keep that socket connection open. We only disconnect from the WebSocket when our application component actually unmounts. So there's a difference here. We have different levels. This is the whole application unmounting and mounting, whereas this is just the room component itself, which will mount once, update a bunch, and then probably unmount once when we close the app. I hope that this helps make it more clear. I know this is a complex example. There are a lot of class-based components in here. Classes themselves is not a massive jump. This context is going to get you a few times maybe, but read this article and let me know if you need help with debugging those types of things. It's definitely something you can learn relatively quickly. I hope today's material gives you some exposure to this stuff, and I hope that you don't think that classes, or that you don't get some idea in your head that classes are better, that they make things easier, because hooks are really the future. Companies are using hooks, and this is really just about class components in the wild. Thank you all so much. Any questions? Otherwise, I am done talking.